Alright, so we already talked about our vertical transformation. So for example, y equals x squared minus 4 shifts our graph down 4 units. And the reason, by the way, if we're thinking about y equals x squared, right, for y equals x squared, for example, we have the ordered pair 0, 0, right? 0 squared equals 0. If we have y equals x squared minus 4, then if we're calculating the y value at an x value equal to 0, we're going to take 0 squared, which is 0, and that's what we got up here, but then we're going to subtract 4, so that gives us a negative 4 for my y value. So for y equals x squared minus 4, we go through the ordered pair 0, negative 4. The y value is reduced by 4. We're subtracting 4 from the original y value from our original function, right? So that's in our vertical shifts. Down here in number 2, we're starting with our horizontal shifts. Horizontal shifts. And these can be a little bit trickier because they're the opposite of what we might initially think. So when you guys see minus 4, if you're choosing between up and down, minus 4, you probably think down. The negative numbers are down on the y-axis. That makes sense. Let's take a look at number 2a. So I want to graph y equals x squared. So x squared. And then next to that, I'm going to use my parentheses. So parentheses, y equals parentheses x plus 2, close the parentheses, and then I can use my squared key. Alright, so let's see what happens. We've got our y equals x squared, our parabola, vertex of 0, 0. And then y equals x plus 2 in parentheses squared. We see that we're shifting to the left 2. So we have a horizontal transformation because we're adjusting our x value, right? So we're messing with our x inside the parentheses. And you might think plus 2, if you're looking at horizontal shifts, you might think that would go to the right because positive 2 is to the right if we're graphing. But this creates a horizontal shift 2 units to the left. So why do we move to the left instead of to the right when we take x and add 2? So if we look at our original function, y equals x squared, we'd have these ordered pairs, and I could list any, but I just picked 0, 0, 2, 4, and negative 2, 4. And this is because our x value 0 squared equals 0, our x value 2 squared equals 4, and our x value negative 2 in parentheses squared also equals positive 4. So that's where those y values come from. Alright, for our transformed function, y sub 2 equals x plus 2 in parentheses squared. If I want to keep these same y values, my y value of 0, my y value of 4, and a second y value of 4, which x values could I put into this function to get us there? So to get a y value of 0, for example, I would want this quantity, x plus 2, to equal 0. And the way I get there is by taking a negative 2 plus 2. That's going to create my 0 squared, right? So an x value of negative 2 is going to give me a y value of 0 for this transformed function. Before it was 0, 0, but if I shift 2 to the left, I end up with that same y value. Before I had the ordered pair 2, 4. If I create x equals 0, if x is equal to 0, then I'm going to have 0 plus 2 in parentheses squared, which is just 2 squared, which gives me 4. So positive 2 squared equals 4. I can get that by making x equal to 0. And also, if I take, let me say, negative 4 plus 2, negative 4 plus 2 is going to give me a negative 2 in parentheses squared, and that also gives me a positive 4. So I've got my ordered pairs 0, 4, negative 2, 0, and then negative 4, 4. These are points on my transformed function. Where for my original function I had 0, 0, 2, 4, and then negative 2, 4. So I can see that from my original blue function to my transformed red function, I had to shift 2 units to the left to get there. So the horizontal shifts are a little bit counterintuitive, when you're adding a positive constant to x, you're going to shift to the left. And down here in part B, when we have x minus 4 into the square root, guess what's going to happen? We're going to shift 4 units to the right. So that's my prediction. Let's make sure that that's accurate. So y equals second square root of x, and then y equals, I'll clear that out, second square root of x minus 4. And by the way, on an older calculator, you'll have square root and then parenthesis. You'll fill in your x minus 4 and then just close the parentheses to make sure that whole thing is under the square root. So there's our square root function, and then shifted to the right 4 units to the right is our function square root of x minus 4. Okay, and we can use the trace key to pull out a few points. I know my original function has 0, 0. Square root of 1 is 1, so 1, 1. And the square root of 4 is 2. 1, 2, 3, 4, 2. And then shifting 4 units to the right, if I hop down, if I put in x of 4, that gets me on y equals 0. 2, 3, 4. If I try to type in x equals 5, that gives me the ordered pair 5, 1, and so on. Alright, so part C says determine without graphing, begin with the graph of y equals absolute value of x. How would you graph y equals x plus 4 inside the absolute value? So remember, with horizontal, it's kind of the opposite of what we would think. Plus 4, initially we might think that takes us to the right, but this will actually shift us 4 units to the left for a horizontal shift. So when we're adding or subtracting numbers from x inside parentheses or inside an absolute value bracket or something like that, plus 4 results in 4 units to the left. Let's just double check that. So absolute value of x, and then math absolute value of x plus 4, the whole thing in the absolute value. There's my original function, and then you can see my transform function scoots 4 units to the left. Part D, determine without graphing. Starting with y equals square root of x, how would you graph y equals square root of x minus 6? Minus 6 is going to push me 6 units to the right. 6 units to the right, and you can double check that in your calculator as well. Part E, begin with the graph of y equals x squared. If you have a positive constant, c greater than 0, how would you graph y equals x plus c in parentheses squared? Well, adding that positive constant is going to move us c units to the left. Part F, if c is positive, greater than 0, how would you graph y equals x minus c in parentheses squared? That's going to move us c units to the right.